This is a review of solving linear systems of equations. Here's an example of such a system. We have two equations, 4x plus 2y equals 10, and x minus 2y equals negative 5. And each of those equations we know represents a line in the xy plane. So when you have a system of two equations like this, each equation represents a line, and the solution of the system corresponds to the point where those two lines intersect. So we're going to use an algebraic approach to try to find that intersection. By the way, sometimes you'll see a system like this written with that notation of curly left brace to group the equations together to make it clear that it's a system that you're trying to solve. So you may or may not see that in a problem. But it's often a good idea to write it when you're working through your own problems to remind you what you're doing. So there are several techniques we can use to try to solve a system like this. The first technique we're going to review is what's called substitution. The idea of substitution is to simplify the problem we're looking at, to use one of the equations to isolate one of the variables. So you'll get an expression for one of the variables in terms of the other variable, which you can then substitute in wherever you see that variable in the other equation. So here's what we mean. I'm going to start by using the second equation and isolating the variable x. So because I have x minus 2y equals negative 5, I can isolate the x in this equation, and if I add 2y to both sides, I get minus 5 plus 2y. Of course, a simpler way to write that so that you have one less symbol to write is 2y minus 5. That's equivalent. This equation, x equals 2y minus 5, tells us x is the same as 2y minus 5. Okay, if for any point on that line, if I plug the y value into the right side, the number I'll get will be the same as the x value of that point. So, since those quantities are the same, and I'm looking for the point where these two lines cross, I know that the x value where they cross can be rewritten in terms of the y value where they cross, and so that point must be on the other line, the 4x plus 2y equals 10 line. So I can replace the x's I see in the first equation with this expression 2y minus 5. Let's see what happens when we do that. So I have 4 times x, but instead of writing the x, I'm substituting 2y minus 5 in place of that x. And I'm leaving the rest of the equation as it was. Now here's the point. We've got a new equation, but it only has one variable in it. Instead of a system of two equations with two variables, now all I have to do is solve this one equation with one variable, which is simpler. And this is a fundamental idea of algebra, trying to reduce a problem to a simpler one we already know how to solve. So let's solve it. I can distribute this multiplication by 4 to get 8y minus 20, and then combine like terms. So on the left side, I have 8y plus 2y, that's 10y. And I'm going to, in the same line, do a second step. I'm going to get rid of the 20 here on the left side by adding 20 to both sides. So minus 20 plus 20 will cancel. And on the right side, 10 plus 20 is 30. Now, this is a simple equation for us. We can isolate y if we divide both sides by 10. So we get y is equal to 3. Now, to completely solve this system, we actually need to know what both variables are, x and y. I already have y, so I need x. How can I get that? Well, I can plug that y value into any one of these equations. I can use the first equation again or the second equation, but actually the easiest thing in this case is going to be to plug it into this equation where we've already isolated x, and since we're trying to find the value of x, having it already isolated will make that easier. So if I plug the 3 in where I see a y, I get 6 minus 5, which simplifies to 1, so x is equal to 1. And my answer for this problem is both of these. X equals 1, y equals 3. That's the complete answer to state both of those. Okay, so this was one approach. This was the substitution approach for solving a system of linear equations. Now, let's try another approach on the same system. We're going to use the addition method this time instead of substitution. The idea of the addition method is similar. We're still going to try to eliminate one of the variables so that instead of a system of two equations with two variables, we end up with a system with just one equation in one variable, which we already know how to solve. But instead of isolating one of the variables so that we can substitute for it, the addition method has us just adding the equations together or multiplying the equation by a number before adding it together. So we can do that in this problem. Actually, we can do a simple version of it in this problem. All I have to do is add the two equations together. So I take 4x plus 2y equals 10 and x minus 2y equals negative 5. Let's add the two equations together. What we mean by that is we're going to add the left sides together and we're going to add the right sides together. So I'm going to have 4x plus x. We'll combine like terms as we go here. So 4x plus x gives us 5x. And then plus 2y minus 2y cancels out. And now we see why this was a useful thing to do, because we've gotten rid of all of the y's. On the right side, when I add them together, 10 plus negative 5 gives me 5. And then I can divide both sides by 5. And I know that x is equal to 1. You'll recall that's the same value we got for x in the previous approach. So now I want to solve for y. I have an x value, and so I can plug this x value into any one of the equations with a y. So you take a look at both of them, and you ask, does either of these look simpler to use? And I think the first equation looks simpler to use, just because we've got a positive coefficient in front of the y. That's not a very strong reason. You could use either equation for this step, but I'm going to pick that one. So what we do now is plug the value we just found for x into either equation, and I'm going to use the first equation. What does that give us? Well, 4 times 1 plus 2y equals 10. So this is 4 plus 2y equals 10. Subtract 4 from both sides, and you get 6. Divide both sides by 2, and you get 3. So y is 3, and earlier we saw x is 1. And that's the same exact set of values we got using the other approach. So you can use either method here. Why would you use one rather than the other? Well, there are things you can look for. You might notice in this problem, because the x had a coefficient of 1, substitution was a pretty easy approach to use. But also, the addition method was pretty easy to use because these coefficients matched up. All we had to do was add them together, add the two equations together to get them to cancel. So in this problem, either approach worked out pretty nice, pretty easy. But there might be times where only one of the approaches really is useful. They're both useful, but one of them is going to be easier sometimes. And those are the things you want to look for. The coefficients and how they might cancel out or make it easier to isolate one of the variables. Let's finish up by just showing you how you might use addition in a different way. What if you could not just add the equations together to get them to cancel? Well, then you can multiply one of the equations by a constant, or you could multiply both equations, each of them by a different constant. Let me show you what I mean. In this system, instead of adding the equations together to cancel the y, I'm going to first multiply the second equation by a number that will let me cancel the x's instead. So in order to cancel the x's, I need the coefficients to be the same. So let's multiply the second equation by 4. So that gives me 4x minus 8y equals negative 5. Sorry, negative 20. Right, because we multiplied everything by 4. 4x minus 8y minus 20. Okay, now what's happening is the coefficient in front of the x is the same in this equation and in the original first equation. So let's subtract to get them to cancel. Subtract this from the first equation. So I have 4x minus 4x, those cancel. 2y minus negative 8y. So let's be careful about that. I'm going to write that out. 2y minus negative 8y. And then on the other side, 10 minus negative 20. So be careful here, we're subtracting our new equation from the original first equation. So I'm subtracting 4x from 4x, I'm subtracting negative 8y from 2y, and so on. Now we can simplify. 2y minus negative 8y is 10y. 10 minus negative 20 is 30. So y is 3. That's good. That's looking familiar like we had before. And then to finish this up, you can plug that y value into any one of these equations to solve for x. So I'll let you finish that on your own, and you'll find that you get x is equal to 1. The last thing we should talk about here is how to check your answer. So let's say you found the solution we did, x equals 1, y equals 3, and you want to make sure you're right. All you have to do is plug that value in to each equation to make sure that the equations work out. So in the first equation, I'm going to replace the x with a 1 and the y with a 3. So that's 4 plus 6, which totals to 10. That's right. That's the value we were expecting to get from the first equation. And when I plug it into the second equation, I'll have x is 1 minus 2 times y, which is 3. That comes out to 1 minus 6, which is negative 5. And that's what we wanted out of our second equation. Since plugging this point in makes both equations work out, it is the solution of that system. It is the set of coordinates for the point where those two lines cross.